Hello and welcome back to module number 5. This is probably the last day of winter here, so I am wearing a sweater and I'm trying to enjoy the cool weather as much as I can. So in module number 5, we are going to talk about a lot of things, but specifically we're going to talk about part to the whole and what is ranking analysis. But I want to start this conversation and again going back a little bit to talk about two dimensions. What is zoom and what is part and the whole, because this is two design concepts that appeared in our textbook, and I think it is important to discuss them because we're going to see them quite often in how the dashboard that you are using, example, in your Canvas dashboard and your bank dashboard, and even in Facebook dashboard, you will see this effect and how they apply to it. So this is a really important aspect with regard to design. In the second part, we are going to I'm going to introduce to you the dashboard called Plotly. Plotly is not open source, but it is a platform that allowed us to run R or Python or JavaScript and to produce visualization. You have to be sneaky in order for you to get in, but the idea of it is that you are able to generate visualization, and it has a very nice mechanism that you can search or see other people work, edit their work, and improve them or make it the worse, and then publish it yourself. So I'm taking you a little bit step backwards just to make sure that we are synchronized with regard to our terminology. So we talked about lines, we talked about points, we talked about coordinate system, and this is our vocabulary, how we talk and how we analyze our visualization, which you're going to start next module. You're going to encounter your first visual peer review to your peers' work, and you're going to start looking at the work in regard to the vocabulary, regarding the points, regarding the lines, regarding the coordinate system, or the numbers, or the colors. So I'm going back to the points that I think I did not do a good job to explain them about the smooth versus the rough. And the idea of the smooth, usually when we are talking about normal distribution, this is called a smooth distribution. We are not looking for extreme, or we are looking at a fit data set that fit into the design theme that we apply to. Also, in the last week, we also talked about averages. I throw away a lot of terms and I don't explain it um, very in depth on that. Single moving averages, central moving averages, potential smoothing, and unavertible times series module, all of that are part of it. I'm not going to go over each of every single one, but I want you to be aware, and this is for future reference because I cannot cover everything. In this class, I'm trying to cover the visual aspect. Each that in that sense, that each value of the visualization helps to communicate the idea, and that's the idea behind it. So I highlight in this module, I'm going to highlight two issues. The first issue is the zoom. And the zoom is usually in the context of the content of the visualization that you are trying. A textbook that we are reading in this class, the Visualize This. The author is Nathan New, and he is part of the RStudio team, and he is really proficient with regard to writing packages. We will use one of his packages called animation in the end of the semester, where we're going to apply the RStudio and his package to generate animation. So he talks about the idea of the term zoom. It is, and he says that it is easy to explore design patterns over time. Time is embedded in our daily life, and so many aspects of visualizing data are fairly intuitive. So he used the term zoom function to explore new dimension of the data. What it does it means? So let's look closely at the three charts that we have here. We have the big pictures to the left, and it consists a lot of data. But the zoom option or the zoom application allowed us to zoom in to look at specific data set instead of looking at the entire data set. That's an issue, and that's an important issue that I want you to think about. When you, in the end of the term, you're going to apply a large data set, and you're going to say, okay, this is what I have, and you will say normal distribution or the mean, it doesn't tell us anything. If you will apply the zoom application and to allow the viewer to look specifically to a specific variable, to specific set, to specific condition, that will make the experience more exciting or more interesting to the viewer itself. So in this module, we are going to look at part and of the whole. And so the terms come from the idea that it is consists of three concepts of the model method, which is a model that deliver from the idea of concept and the change of the concept. The best way to visualize it, but beforehand, there's three balls. Bob has two balls. How many balls does do they have all together? So Anne has two balls. Bob has Anne has three balls. Bob has two balls. How much do they have together? Altogether, they have five balls. So the idea here is that we are breaking down the whole, and it is 3 plus 2. Therefore, we have five balls altogether. So the idea here is that according to our textbook, the most frequent and simplest type of analysis involving comparing part of the whole is ranking them by the value. And this is important. Why? Because one of the things that nowadays the bank system dashboard has allowed us to do is give us a screenshot of our salary, a total monthly expenses, totally monthly saving, and the cash balance in order for us to understand the whole versus what we actually spend, how much we save, which is the part of the whole. The whole is how much monthly income do we have. So the idea of the whole and the ranking patterns or design patterns, we have different patterns that we can apply to. Uninformed, usually all the values are lined up in the same. Uninformally different, which is different from one value to the next, decreasing through the same amount. And non-uniformly different, differences from one value to the next significantly. And yes, it doesn't change the design, but it changes the context of the design that you are looking for. Pie chart often compares either two 2D areas formed from each size of or the angles formed from each where the slice meet at the center. That's the idea of the whole, right? So, however, pie charts are usually especially time consuming when we need to interpret the the distribution if it's a large data set. So it requires a very good eyesight in order for you to do that. Like your professor doesn't have one. So in the issue of that, this is something that is really up to you when you are designing a pie. You need to take into account that a lot of people, like your professor, do not see so well. So the best practice in the pie is grouping categorical items as one as an ad hoc manner. So one of the recommendations based on our textbook is using a specific type of charge with a percentage scale. That way, we will be able to show the different percentage and be able to display that. And then other recommendation that author has is expressing value to solve scaling problems and using line graph to view ranking changes through time. So the idea of this type of visualization, it's basically a bar chart with a line that shows the time frame that goes through that, is the ability, and that with regard to grouping categorical items, is the ability to group categorical items and display them together so the reviewer can see more than one category. More example of this type of chart. Again, this is a good example of a good chart. You have a sense of what's going on with that idea. If you are into Excel, this is a good link to it that allowed you to do that in Excel. I do not recommend that, but some of my previous students really like Excel, so this is a good reference to it. One of the other aspect that our textbook talk about is re-expressing value to solve scaling probability. When a set of ranked value across a large scale, sometimes lower levels, barely register on the graph, and as a result, it's hard for us to see and make a comparison. So our textbook recommended viewing the lower values independently in a separate graph, which means that lower level, entire level, in order for the viewer to give more insight into what it is. The second recommendation is the scaling the value by involving the re-examination of the values so that they are eventually distributed across the scale in a single graph. This type of scaling should be used with cautious. Why? We, we do not want you to lie in your data set. So you need to be very careful when you do that. But this is a really good, efficient way for us to display the data. Three, expressions that our textbook use is square root of the expression, logistics re-expression, and inverse re-expression. So if you start with re-examining the values using the square root, but problems persist, move on to the next. So what he recommends basically is if you can take the values and square root them, will it affect? If it does not affect, you need to move to the next one. So the next one, the square root of the idea is based on the idea that calculate the square root of the medium and to calculate it on the sum of the value and the square root of it. The next one is basically, again, taking the big values or the summary of the variables and dropping the 50% out of it in order for you to examine it. Again, it can have an effect, it might not have effect. You are the judge of it. You need to take cautious when you do that because sometimes it will look suspicious when you do that. So you declare it and make sure that the viewers understand it. The last recommendation is the inverse. The expression is changing the direction of the graph from lower to highest or vice versa. So instead of displaying the lowest to the highest, change it and see if the order, the normal order of the organization of the map actually makes sense. So this is my very short, but I think important discussion of the part versus the whole. And I want you to think about that. When you are presenting a large data set, example, 2 million records, and you are looking for the mean or the standard deviation of this number and it doesn't come out, break it down, break it into a part so we will be able to understand what it is. Second part is, as I said, is introduction to Plotly. Okay, so there's little tricks that I want you to learn about Plotly, and I think it's important to know them because if you are not familiar with Plotly, Plotly can be a little tricky. It is a Canadian company, and if you log on to plotly.com, they will ask you for money, and this is part of how they do the business. But if you will log on to chat/studio.plotly.com, you will see that you will have a public platform where you can use it. You're going to create your own username and password. It will be on your browser. You don't need to download anything underneath. And when you create the dashboard, this is something that is really cool because it allowed us to search for specific items and you can see what type you want the dashboard, you want the chart, you want what type of a plot you can generate and so on. So in this case, I search for Super Bowl because I recorded this module before the Super Bowl and I said I want to see all the Super Bowl example and I said search and it doesn't come, of course. So oops, sorry, my mistake, played you with too many items. So again, the issue of the Super Bowl and how to apply to it and what does it really mean. The issue is that when you get into the dashboard, you can generate a new chart, and a new chart will you will ask you to upload or link to a database, or you can take someone else that use the Plotly dashboard to use it. You going to apply the dashboard. The dashboard will be empty and you're going to add some text and add some dimension to it, and you have a very good help that allowed you to go over the tutorial to see what's going on. So I'm going to go over the tutorial to make sure that we all have the same idea about the help and how to generate it. So my connection because of what I did. So how to sign, how to import data, create a chart using Excel, and using the pen or the panel over it, and view plots. And this is really good because it allowed you to see how to apply and how to create different type of plot. You can always see the data, see how the code imply to it. I do not ask you to generate your own code, but what I want you to do is to create a chart. And in this case, this is a chart. You can import the data. Import, wait, import, sorry. So you can upload your own file. You can use your URL. You can use examples already exist. And I will use, I think I don't get my own files. So this is my own files. I'm going to go to the editor. And as you can see, this is my data. Now the issue of what do I do with it? How to apply? It will give me options, and he will ask me if that works for you or not, if he will apply. So I can create with white background, classic background, or gray background, or black. And this is quite cool. And I can have general with regard to the style. I can have adding more dimension to it. I can add shapes, lines, and I can have the shape. So in this case, this is my data. I selected the data. I can have what type of data I can have here. I can have time. I label each scale. I label it and I measure it, so it will give me more dimension. I can change the dimension and I can convert it into those dimensions. So basically, it's a very simple methodology and allowed us to apply and demonstrate the ability to do that. And this is the beauty of it. And you can do trace. You can add the 3 dimension that I have in my data set. And I can define what is the x's and what is the y's. And I can change the dimension. It will not be easy on the first take. I want you to take time. This is part of your exercise. How to go step by step in order for you to generate a successful, create your own first Plotly visualization. I hope you enjoy it. If you have any question, please do not hesitate. Until next time, have fun and enjoy Plotly.